3 billion miles from Earth lies a dark, frigid world. But as we delve beneath the surface of Pluto, we find a world that's not just endlessly cold and remote, but surprisingly alive. Plunge with us beneath miles of ice into sunken oceans that could defy everything we know about the potential for life in the far reaches of our universe. What we discover in Pluto's shadowy waters may forever change our understanding of what thrives in the darkness among the distant stars. Once considered nothing more than a tiny, frozen cosmic rock, Pluto has emerged as a place of bewildering potential. Recent glimpses of Pluto have revealed startling evidence that this distant orb likely hides a vast interior ocean beneath its crust of nitrogen and methane ices. Even more astounding is the possibility that this subterranean sea could actually sustain living organisms. Pluto holds the key conditions for life: liquid water, organic compounds, and an internal heat source to warm the ocean. The implications are staggering. Could Pluto's sunless depths be home to alien life forms? Pluto was initially hailed as the ninth planet upon its discovery by Clyde W. Tombaugh. In 1930, it later met doubts regarding its planetary status due to its small size and the discovery of similar objects in the Kuiper Belt. Pluto was labeled as a dwarf planet by the International Astronomical Union in 2006, which redefined the term planet. Despite this, some astronomers still consider Pluto and other dwarf planets to be planets. Pluto has 5 moons: Charon, which is the biggest one, Styx, Nix, Kerberos, and Hydra. Pluto and Charon are an intriguing pair as they are sometimes regarded as a binary system. Their center of mass, or barycenter, doesn't lie in either body, and they are tightly locked to each other. Until 2015, we didn't know much about the size or surface conditions of Pluto because it's so far away from Earth. That was changed by the New Horizons spacecraft's close flyby of Pluto. This mission revealed that Pluto has a diameter of about 1,470 miles, which is less than 1/5 the diameter of Earth and only about 2/3 as wide as our moon. The New Horizons spacecraft also provided detailed observations of Pluto's surface, uncovering various features. Among these are mountains that rise as high as 11,000 feet, comparable in size to the Rocky Mountains on Earth. Despite the presence of methane and nitrogen ice covering much of Pluto's surface, these materials aren't sturdy enough to support such massive peaks. Scientists believe that these mountains are formed on a base of water ice. Pluto's surface is covered in an abundance of methane ice. The way this ice reflects light varies across Pluto's surface. There's also a unique ice-ridged terrain in a snakeskin pattern, with features similar to Earth's penitent, which are erosion-formed structures on mountainous terrain. But Pluto's versions of these features are much larger, reaching an estimated height of 1,650 feet, 500 meters, whereas Earth's penitents are only a few meters tall. A spectacular feature on Pluto's surface is a large, heart-shaped area informally called the Tombaugh Regio. It's like the planet has a large heart emoji on its surface. One part of this region looks like an ice cream cone and is covered in carbon monoxide ice. Variations in the composition of surface materials have also been identified within the heart of Pluto. Toward the center left of Tombaugh Regio is a very smooth region, unofficially known as Sputnik Planum. The lack of meteorite impacts suggests that this area is relatively young in geological terms, perhaps less than 100 million years old. Ongoing geologic processes might continue to shape this region. These icy plains also have dark streaks that are a few miles long and all going in the same direction. It is believed that these lines are the result of strong winds blowing across Pluto's surface. Observations from NASA's Hubble Space Telescope also show that Pluto's crust might have complex organic molecules. Over time, it seems to have become redder, probably because of seasonal changes, as seen in images from the Hubble Space Telescope. There is also an ongoing debate about whether Pluto has a subsurface ocean. It is possible that this could have significantly influenced Pluto's history. One theory suggests that the weight of ice in the Sputnik Planitia region altered Pluto's orientation. It is estimated that the ice here is 6 miles thick. A subsurface ocean is the most likely explanation for this phenomenon, but other possibilities, like a thicker ice layer or movements in the rock, are also being considered. Some scientists even think that Pluto could be a place where life could flourish if it has a liquid ocean and enough energy. According to NASA, Pluto's atmosphere is composed mainly of methane and nitrogen. The New Horizons mission found that Pluto's atmosphere extends to 1,000 miles above its surface. It's not clear if Pluto has a magnetic field. However, due to its small size and slow rotation, it is likely that Pluto has a weak or no magnetic field at all. Pluto is thought to be made up of about 70% rock and 30% water ice. Inside Pluto, there's likely a solid rocky core at the center, surrounded by a layer of water ice. These characteristics provide us with a deeper understanding of what Pluto is like and how it is structured. Pluto follows an eccentric orbit around the Sun, making it more elongated than the circular paths of most planets. During Pluto's 248-year orbit, it comes closer to the Sun than Neptune, giving astronomers a rare chance to study this cold, distant world up close. The eccentric orbit's impact extends to Pluto's atmosphere. The surface ices thaw closer to the Sun, creating a temporary nitrogen-rich atmosphere with traces of methane. Pluto's weak gravity allows this atmosphere to reach higher altitudes than Earth's atmosphere does. As Pluto moves closer to the Sun, its atmosphere freezes and diminishes, but during its atmospheric phases, it experiences strong winds. The atmospheric brightness variations could be caused by gravity waves or airflow over mountainous terrain. Even though current conditions don't allow for liquid flows, evidence shows that there was once liquid activity on Pluto's surface, like a frozen lake in the Tombaugh region. In the past, Pluto may have had an atmosphere 40 times thicker than Mars's current atmosphere. NASA's New Horizons spacecraft, which carries a portion of Clyde Tombaugh's cremains, launched in January 2006, achieved a historic feat by closely examining Pluto, its moons, and Kuiper Belt object. Due to limited knowledge of the Pluto system during its launch, the mission faced exceptional challenges. At that time, scientists were aware of only 3 of Pluto's moons. In 2016, the New Horizons mission unveiled a fascinating discovery: the potential presence of clouds in Pluto's atmosphere. There were 7 distinct features that appeared cloud-like around the terminator, where light and darkness collide on the dwarf planet. These clouds are likely composed of acetylene, ethane, and hydrogen cyanide. This information helped us learn more about Pluto's complicated and moving atmosphere. The mission's unexpected discovery of 2 more moons, Kerberos and Styx, sparked concerns about hidden moons that could pose potential dangers. Even though there were difficulties, New Horizons made history in October 2021 by showing us the first close-up pictures of Pluto and its moons. This helped us learn more about Pluto and the Kuiper Belt region. NASA's New Horizons spacecraft unveiled a world that exceeded all expectations in terms of its dynamism and beauty when it encountered Pluto in 2015. This once mysterious dwarf planet has amazing features, like icy cliffs that look like Norway's rugged coast, huge methane ice formations that reach skyscraper heights, and deep chasms. A lot of the icy volcanoes were higher than Mount Everest. Leslie Young, a planetary scientist at the Southwest Research Institute in Boulder, Colorado, and a deputy project scientist on the New Horizons mission, expressed her amazement, saying, "I expected Pluto to be a scientific wonderland, but it did not have to be so beautiful." Although these initial photographs may not possess the same level of sharpness as the more recent ones, which are capable of discerning features as small as 75 meters, they nevertheless provide valuable insights into Pluto's terrain at resolutions ranging from 2 to 30 kilometers. This represents a significant enhancement in comparison to the images captured by the Hubble Space Telescope, which exhibit a lower resolution. These images are rich in information and represent the best information available for the next few years. Scientists are gaining a fresh perspective on this dynamic world, with a wealth of images to study. These images are helping researchers understand how Pluto was formed, including the possibility of an ocean underneath its icy surface and the ways in which atmospheric compounds freeze out and shape its surface. The data supports the idea that Pluto could be a suitable environment for life, despite its frigid environment. These images also present puzzles. Interestingly, The tall ice structures that look like skyscrapers were seen before on Pluto's near side. However, now they appear to surround Pluto, which is a big mystery. Pluto continues to be a source of scientific interest and discovery. During Pluto's transit in front of a distant star in 1988, scientists were able to study the light from the stars as they passed through Pluto's atmosphere. This allowed them to identify the various elements found in Pluto's atmosphere. The Hubble Space Telescope offered valuable assistance in 1996 by delivering images of Pluto's surface with a magnification of 500 kilometers. These early images were somewhat obscure, but they offered a glimpse of the world, displaying more significant contrasts on a large scale than any other celestial body. These observations suggested the possibility that Pluto may be a dynamic world, a notion that was confirmed in July 2015 when NASA's New Horizons spacecraft famously detected a heart-shaped feature on the near side, located just north of the equator. Within this heart-shaped region lies Sputnik Planitia, an icy basin hosting substantial glaciers that are in constant motion. This significantly influences Pluto's activity. As sunlight warms the frozen plains of Sputnik Planitia, ice turns to vapor, rises, and then falls back down as the day goes on. This dynamic region may have even played a significant role in the tilting of Pluto on its axis. Soon after the arrival of the first images from the near side, scientists, including Francis Nimmo, a planetary scientist at the University of California, Santa Cruz, realized that the location of Sputnik Planitia was peculiar. It is almost exactly in line with Pluto's biggest moon, Charon, and the chance that this is just a coincidence is 5%. Scientific models suggest that when the basin formed, an underground ocean flooded into the depression. Later, the nitrogen gas present in Pluto's atmosphere condensed and froze within this frigid basin. The accumulation of water and ice created a substantial load, which led to Pluto's current axial orientation. The idea of a subterranean ocean was previously considered, but the images of Pluto's far side provided ample evidence to back up this notion. A key piece of evidence is the presence of chaotic terrain, a complex mix of ridges, fractures, and plains found on the opposite side of Pluto from Sputnik Planitia. Pluto has some intriguing geological features, particularly numerous cracks on its far side, which provide additional support for the existence of a concealed ocean and insights into its formation. The far side of Pluto is characterized by an extensive crack that extends from the near side, crosses the North Pole, and then stretches back down toward the South Pole on the far side. This effectively encircles the entire dwarf planet. This crack looks like the East African Rift system on Earth, which is splitting the African continent in two. But unlike Earth's rift, Pluto's is not a sign of changing continents, but is more likely a result of the ocean freezing and then expanding. The crack's considerable age proposes that the liquid ocean began to cool rapidly. The geological characteristics of Pluto are particularly intriguing, with numerous cracks on its far side, proving the existence of a hidden ocean and shedding light on its origins. The New Horizons spacecraft's data serves to create a virtual journey over Pluto, taking us above the plains in the southwest, along the western border of the icy expanse known as Sputnik Planitia, and finally over the sloping terrain to the east. Findings from the far side of Pluto provide additional support for this hypothesis. They reveal the presence of a reddish band, likely composed of organic material, stretching across the equatorial region. The area experiences the most considerable amount of sunlight and a milder climate. The significance of these findings is emphasized by Alan Stern, a planetary scientist at the Southwest Research Institute. He points out that astrobiologists suggest that for life to be sustained, you need three key elements: liquid water, organics, and a source of energy. The evidence for liquid water is compelling and growing stronger. Now, with the discovery of organics, two of the three essential components are accounted for, marking a significant step forward in our understanding. In addition to contributing to the investigation of potential life on Pluto, the data from the far side has introduced several intriguing puzzles. When the initial images from New Horizons were received, Scientists were intrigued by an unusual landscape on the near side, particularly in the easternmost region. The terrain was dominated by towering ice formations, each of which could reach heights as remarkable as 1 kilometer, are spaced fairly evenly, and span over a 30-kilometer span. These striking features presented a formidable obstacle for navigation, resembling a dreadful landscape. However, their significance was made clearer when the far-side images were examined. While the latest map does not provide enough resolution to discern individual ridges, it is evident that the bladed terrain wraps around the entire far side and reemerges on the western edge of the near side in a previously unidentified manner. These formations are 3.5 times bigger than what they are on the near side, making them one of the most mysterious parts of Pluto's landscape. Alan Stern, the principal investigator of the mission, emphasizes the shift in perspective and notes that these formations have transformed from an intriguing and exotic footnote into a subject of significant importance. The analysis of spectral data has revealed that the bladed structures are primarily composed of methane ice and encircle Pluto's equator, particularly on plateaus and mountains. The exact way in which they came about remains a mystery. There are two main theories. These formations may have been made when methane in the atmosphere froze out, like frost on the ground on Earth. A previous layer of methane ice that was gradually eroded by intense sunlight is suggested as the reason for these ridges. Some researchers think that these sharp ridges are similar to penitents, which are found in the high Andes, but on a smaller scale. A planetary scientist at NASA Ames Research Center, Jeffrey Moore, suggested in 2017 that the features on Pluto could be caused by a similar process. Researchers do point out, though, that this explanation fails to account for all the peculiarities of these frozen ridges. The alternative idea of methane precipitation has its own set of challenges, as there is no observable bright frost associated with these formations. One evident thing is that understanding these icy shards, as well as Pluto's overall terrain, necessitates a thorough investigation of the dwarf planet's weather patterns. Recent climate modeling shows that methane tends to build up at higher altitudes, while nitrogen builds up in the lower atmosphere. This is why the Sputnik Planitia Basin is mostly made up of nitrogen ice, while the bladed terrain is mostly made up of methane ice. The bladed ridges on Pluto's surface seem to have been there for a long time. The formation of such impressive heights via the condensation or sublimation processes would take tens of millions of years. Changes in Pluto's past climate could be a factor influencing their formation and location, as they are distributed across a wide range of latitudes. However, the details of these climatic changes still require further investigation. One intriguing aspect of Pluto's climate is its unique seasonal cycle. Unlike Earth, where seasons are primarily influenced by the tilt of the planet's axis relative to the Sun, on Pluto, the seasons are dictated by its axial tilt and the variations in its elliptical orbit. Pluto's orbit takes it from the distant outer solar system to much closer to the Sun, nearly halving its distance from the Sun. This complicated interaction of orbital parameters creates a superseason. In one hemisphere, every 900,000 years, researchers believe that this phenomenon may have affected the latitudinal locations where the bladed terrains formed, although precise calculations of orbital parameters beyond the last 10 million years remain challenging. As our understanding of Pluto grows, scientists are embarking on further investigations. Some researchers are examining the near-side images of Pluto to gain insights into its current seasonal dynamics, aiming to predict potential changes that a future orbiter might observe if launched in the coming decades. The prospect of such an orbiter mission is being looked into by NASA, although it would likely not take place until the 2030s or even the 2040s. The next probe to Pluto would represent a long-term endeavor, encompassing a 15-year journey to reach the dwarf planet. Meanwhile, scientists will continue refining climate models, conducting lab experiments to simulate Pluto's atmospheric and oceanic chemistry, and utilizing advanced instruments like the James Webb Space Telescope. While the Webb telescope may not provide extremely high-resolution images of Pluto, it will offer insights through longer wavelengths, potentially uncovering new discoveries. With increasing questions, the fascination for Pluto is ever present. Even though researchers and scientists have a fair amount of information about the planet, they haven't been able to confirm the existence of the planet's icy waterbed. There is hope, though, as numerous future missions like the Pluto Kuiper Express should feed us more information about the lesser-known attributes of this dwarf world. So what do you think? Does Pluto really have water oceans with life? Or is there something even more mysterious lurking in its shadows? Let us know in the comments below. If you like this video, consider hitting that like button and subscribing to our channel. As always, thanks for watching,